Good day, students. Our discussion for today is about the Pythagorean Theorem. The goal of the lesson is to derive the Pythagorean Theorem. Next, to apply the Pythagorean Theorem in finding the measure of the missing side of a right triangle. And then lastly, to solve real-life problems using Pythagorean Theorem. Let us start by reviewing the similarities in a right triangle. In a right triangle, the altitude drawn to the hypotenuse separates the triangle into two triangles, each of which are similar from the original right triangle and from each other. To illustrate, we have a right triangle ACB. There is an altitude CD, which separates right triangle CDB and another right triangle ADC. Right triangle CDB is similar to right triangle ADC and at the same time similar to right triangle ACB. Since the triangles are similar, therefore their corresponding sides are proportional. Now let us use the concept in the derivation of Pythagorean theorem, where the right triangle CDB is similar to the right triangle ADC and at the same time similar to the right triangle ACB. Suppose the length BC is represented by small letter A, then AC is represented by small letter B, AB is represented by small letter C, and then BD is represented by small letter X, then AD is C minus X. In triangle CDB and triangle ACB, we can produce the proportion X over A is equal to A over C, and that is shorter leg over the hypotenuse of right triangle CDB and right triangle ACB. By cross product, this will become A squared is equal to CX. On the other hand, in the right triangle ADC and the right triangle ACB, we have the proportion C minus X over B is equal to B over C. That is longer side over hypotenuse of right triangle ADC and right triangle ACB. By cross product, this is equal to B squared is equal to C squared minus CX. Adding the two equations, we have A squared plus B squared is equal to CX plus C squared minus CX. In the equation, we can eliminate CX and negative CX. Therefore, we have A squared plus B squared is equal to C squared. And this is our Pythagorean theorem. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the square of the other sides. To illustrate, in a right triangle CBA, suppose the lengths of the sides BC is represented by small letter A, AC is small letter B, AB is small letter C. C is the hypotenuse, then A and B are the sides. In symbol, it is written as A squared plus B squared is equal to C squared, or you may use C squared is equal to A squared plus B squared. Moving on, let us use the Pythagorean theorem to answer these illustrative examples. In a right triangle ABC given below, If BC is equal to small letter A, AC is equal to small letter B, and AB is equal to small letter C, find the unknown measure of the following. Number 1. Find AB if BC is equal to 3 centimeters and AC is equal to 4 centimeters. In the figure, AB is the hypotenuse. Using the Pythagorean Theorem, C square is equal to A square plus B square, it will become C square is equal to quantity 3 centimeters square plus quantity 4 centimeters square. Then, 3 centimeters square is equal to 9 centimeters square. 4 centimeters square is equal to 16 centimeters square. 9 centimeters square plus 16 centimeters square is equal to 25 centimeters square. Then extract the square roots of both sides. That is, the square root of C square is equal to C, and then the square root of 25 centimeters square is equal to 5 centimeters. Finally, AB is equal to 5 centimeters. Using the same figure, let us answer number 2. Find AC if BC is equal to 4 centimeters and AB is equal to 10 centimeters. In the figure, AC is represented by the small letter B. So in the Pythagorean Theorem, A square plus B square is equal to C square. It will become quantity 4 centimeters square plus B square is equal to the quantity 10 centimeters square. 4 centimeters square is equal to 16 centimeters square. 10 centimeters square is equal to 100 centimeters square. By addition property of equality, this will become B square is equal to 100 centimeters square minus 16 centimeters square. 100 centimeters square minus 16 centimeters square, it will become 84 centimeters square. Then extract the square roots of both sides. The square root of B square is equal to the square root of 84 centimeters square. Here, as you notice, 84 is not a perfect square, so we cannot extract the square root of 84. But we can simplify 84 and have the factors, and that is the square root of B square is equal to the square root of 4 times 21 centimeters square, because 4 times 21 is equal to 84. The square root of B square is equal to B, and then the square root of 4 is equal to 2, and then 21 still remain inside the radical sign. So finally, our answer is AC is equal to 2 square root of 21 centimeters. Number 3, find BC if AC is equal to 5 centimeters and AB is equal to 13 centimeters. In the figure, BC is represented by small letter A. So using the Pythagorean Theorem, A square plus B square is equal to C square. Then substitute the values. It will become A square plus quantity 5 centimeters square is equal to the quantity 13 centimeters square. 5 centimeters square is equal to 25 centimeters square. 13 centimeters square is equal to 169 centimeters square. By addition property of equality, this will become A square is equal to 169 centimeters square minus 25 centimeters square. 169 centimeters square minus 25 centimeters square is equal to 144 centimeters square. Then extract the square root of both sides. The square root of A square is equal to A, and then the square root of 144 centimeters square is equal to 12 centimeters. Finally, our answer is BC is equal to 12 centimeters. To continue, let us apply Pythagorean Theorem in a real-life situations. Let us have number 1. A 10-meter ladder is leaning against the wall. The ground is 6 meters from the wall. How high up the wall does the ladder reach? To illustrate in a right triangle, the hypotenuse will be the 10-meter ladder. Its distance from the wall will be 6 meters, and then the height reached by the ladder will be represented by small letter b. In a Pythagorean theorem, a square plus b square is equal to c square. It will become quantity 6 meters square plus b square is equal to the quantity 10 meters square. 6 meters square will be 36 meters square, then 10 meters square will be 100 meters square. Then, by addition property of equality, this will become b square is equal to 100 meters square minus 36 meters square. 100 meters square minus 36 meters square is equal to 64 meters square. Extracting both sides, the square root of b square is equal to the square root of 64 meters square. The square root of b square is equal to b, and then the square root of 64 meters squared is equal to 8 meters. Finally, our answer is the height reached by the ladder is 8 meters. Number 2, if a traveler walks 12 kilometers east and then 5 kilometers south, how far is he from the starting point? To answer this, let us illustrate first in a direction map, wherein the upper portion will be the north, the lower will be the south, the left side will be the west, and then the right side will be the east. The middle of this direction map will be the starting point of every traveler. So from the starting point, he goes to the east by 12 kilometers. And then from the east, he goes to the south by 5 kilometers. And then the missing measurement is the distance of this traveler from the point where he is started. From the right triangle, it is the hypotenuse. Let us use the Pythagorean Theorem. C squared is equal to a squared plus b squared. Let us substitute the values. So we have c squared is equal to the quantity 12 kilometers squared plus the quantity 5 kilometers squared. 12 kilometers squared is equal to 144 kilometers squared. 5 kilometers squared is equal to 25 kilometers squared. 144 kilometers squared plus 25 kilometers squared is equal to 169 kilometers squared. Extracting both sides of the equation, we have the square root of c squared is equal to c, and then the square root of 169 kilometers squared is equal to 13 kilometers. Therefore, the traveler is 13 kilometers from where he is started.